Imagine standing in the middle of an open field at night. Above you stretches the sky, scattered with stars that seem impossibly far away. Around you lies the earth, stretching out in every direction. A vast three-dimensional landscape that you can walk through, touch, and experience. You can move forward and backward, left and right, up and down. These are the familiar coordinates of your life, the 3 dimensions of space. Add to that the flow of time, and you have the stage on which the entire play of existence unfolds. It feels complete, as if reality itself is contained within these 4 dimensions. But what if this is only a fraction of the truth? What if the universe is built on foundations we cannot see, hidden layers of reality that exist all around us, invisible yet profoundly real? This question has haunted scientists, philosophers, and dreamers for centuries. Are there more dimensions than the ones we experience? And if so, why can't we see them? The answer, it turns out, is both unsettling and fascinating. To grasp the idea, we first have to re-examine what we think we know about dimensions themselves. At its simplest, a dimension is a direction in which you can move. A creature living in a one-dimensional world, for example, would only be able to move forward or backward along a line. To such a being, the idea of stepping sideways simply wouldn't exist. A two-dimensional creature, on the other hand, would have more freedom. Forward and backward, left and right, like living on a sheet of paper. But it would still lack the ability to move upward or downward. Imagine such a flatland being, trapped in a world of only 2 directions, trying to comprehend what up means. To them, it would be a concept beyond imagination. Now place yourself in their position. You and I are 3-dimensional creatures. We can move through space in all the ways we know, yet we are just as trapped as the flatland creature. We cannot see beyond our 3 spatial dimensions. The question is, does something lie beyond them? And if so, could it be that we are simply unequipped to perceive it, just like the flatland being who cannot imagine up? Scientists call this line of thought higher dimensional space. And while it might sound like pure science fiction, it is very much alive within the most cutting-edge branches of physics. Some of the most powerful theories of the universe, including string theory, suggest that reality could have as many as 10 or even 11 dimensions. The twist, however, is that most of these dimensions are invisible to us. They are hidden, curled up so tightly at scales far smaller than atoms, that our senses and even our most advanced tools cannot detect them directly. But before diving into the mysteries of hidden dimensions, let's step back and look at the dimensions we already know intimately. Length, width, and height form the framework of space. These 3 dimensions are how we describe every object we encounter. A book has height and width. A room has depth. A tree grows upward. Its branches spread outward. Its roots dig down. Even the planet itself, the galaxies, the universe, they all unfold across these 3 spatial coordinates. But as soon as we add time into the picture, things grow far more mysterious. Time is often called the 4th dimension. Unlike space, we cannot move freely through it. We are carried forward at a steady pace, unable to step sideways into the past or leap forward into the future. Time, in this sense, is like a river that pulls us along. It gives our experience order, a before, a now, and an after. Einstein's theory of relativity showed us that space and time are not separate entities at all, but woven together into a single fabric, space-time. When something massive like a planet or star bends that fabric, it creates what we feel as gravity. This was the first real hint that the universe is stranger than we once believed. For centuries, humans thought of space as just an empty stage on which matter plays. But Einstein revealed that space and time themselves are active participants in the cosmic dance. And if that is true, perhaps the structure of reality is far more intricate than our senses suggest. To help us imagine the possibility of unseen dimensions, let's return to the story of Flatland. Imagine our two-dimensional creature again, living its life on a sheet of paper. It has no awareness of the third dimension, up and down. If you were to reach into its world by placing your finger on the paper, what would it see? It wouldn't see your whole finger. Instead, it would only perceive a cross-section, a circle, the slice of your finger where it intersects its plane. If you moved your finger upward, the circle would vanish. To the Flatlander, your sudden appearance and disappearance might look like magic, even though it was simply the effect of living in a lower dimensional world. Now, think about what that means for us. If there really are higher dimensions beyond the three of space and the one of time, then beings or objects that exist there would be largely invisible to us. We would only perceive tiny cross-sections of their existence. They might pass through our reality in ways that seem impossible, much like your finger passing through Flatland. From our perspective, such events could look like sudden appearances, disappearances, or strange distortions of space itself. This leads to an unsettling but fascinating thought. Could some of the mysteries of our universe, dark matter, dark energy, gravity's peculiar weakness, be explained by hidden dimensions leaking into our world? Could entire realms of existence be just out of reach, brushing against our reality, unseen but ever present? These questions are not only philosophical. Physicists have been trying to answer them for decades. Some of the greatest breakthroughs in modern science, like string theory, are built on the idea that the universe is more than it seems, that dimensions beyond our comprehension hold the key to unifying all of physics into a single elegant framework. And so, as we stand in that open field at night, gazing into the stars, we might realize that we are like the Flatland creature staring at a line, unaware that just above its head lies an entire universe. For us, perhaps, the same is true. Hidden layers of reality may surround us, unnoticed, waiting for the day we find a way to see beyond the boundaries of our perception. If extra dimensions exist, the next question becomes, where are they hiding? If they are so crucial to the structure of reality, why haven't we seen them? The truth is, we might not be looking in the right way, or perhaps our eyes simply aren't built to notice them. One of the most daring attempts to explain hidden dimensions comes from string theory, an idea that tries to unify all of physics into a single, elegant framework. According to string theory, the smallest building blocks of reality aren't particles, as we once thought, but vibrating strings of energy. These strings are unimaginably tiny, so small that if an atom were the size of our solar system, a string would still be invisible to the naked eye. Yet the way these strings vibrate determines everything: the particles, the forces, the very laws of nature. But here's the strange part. For string theory to make sense mathematically, our universe needs more than just 3 dimensions of space and 1 of time. It needs at least 10 or 11 dimensions. Without them, the equations fall apart. It's as though nature itself demands the existence of hidden dimensions to function properly. So why don't we notice them? The answer lies in a concept called compactification. Imagine a tightrope stretched across a canyon. From far away, it looks like a one-dimensional line. A tiny ant, however, walking along the rope, would notice something more. Not only can it move forward and backward, but it can also crawl around the rope's circular surface. What looked like a simple line from a distance actually has an extra hidden dimension, curled up so small that it goes unnoticed unless you're close enough to detect it. String theorists believe the universe works in a similar way. The dimensions beyond the three we know may be curled up, compactified into tiny loops at scales far smaller than atoms. To us, the world appears three-dimensional, just as the rope appears one-dimensional to an observer standing far away. But in truth, space could be woven with countless hidden folds and twists too small for us to see. This idea isn't just abstract math, it has fascinating consequences. For one, it might explain why gravity is so weak compared to the other fundamental forces. Think about it. The electromagnetic force is powerful enough to push apart two magnets. The nuclear forces hold the cores of atoms together with immense strength. Yet gravity, the force that binds the cosmos, is surprisingly feeble on small scales. Why does a simple refrigerator magnet easily overcome the gravitational pull of the entire Earth on a paperclip? Some physicists suspect that gravity's weakness could be because it is leaking into hidden dimensions. While forces like electromagnetism are confined to the dimensions we see, gravity might be able to spread itself thin across extra dimensions, diluting its strength in our three-dimensional slice of the universe. If this is true, then gravity itself may be the key that hints at dimensions beyond our view. This brings us to one of the earliest serious proposals of an extra dimension, Kaluza-Klein theory. In the 1920s, a physicist named Theodore Kaluza suggested adding a fifth dimension to Einstein's equations of general relativity. To his surprise, the mathematics revealed not just gravity but also electromagnetism, the two most important forces known at the time. Oscar Klein later expanded the idea, suggesting that this fifth dimension was curled up, hidden from everyday experience. Though Kaluza-Klein theory eventually faded into the background, it planted an important seed. It showed that by adding extra dimensions, the universe's forces might unify. Nearly a century later, string theory picked up that idea and expanded it, giving rise to a framework that attempts to unify all forces, gravity, electromagnetism, and the nuclear forces, into one grand theory of everything. But string theory's extra dimensions aren't just sitting there quietly. Their shapes, their geometry, and the way they're compactified could actually determine the very nature of our universe. Imagine two different ropes, one circular, one twisted. The ant walking on each would experience the world differently. In the same way, if the extra dimensions are curled in one shape, they might give rise to our familiar universe. If they were curled differently, the universe itself could look completely alien. This idea leads to something even more mind-bending, the multiverse. If extra dimensions can take on countless shapes, then each shape might correspond to a different universe with its own physical laws. Our universe, in this sense, could just be one possibility among an unimaginable number of others. Perhaps, somewhere in the vast sea of possibilities, there exist universes with different versions of you, living under entirely different rules of physics. To test whether these hidden dimensions are real, scientists have turned to the most powerful machines ever built, particle accelerators. At facilities like the Large Hadron Collider (LHC), in Switzerland, particles are smashed together at nearly the speed of light. These collisions briefly recreate conditions similar to those at the beginning of the universe, potentially revealing signs of extra dimensions. How could we detect something that we cannot see directly? One possibility is to look for missing energy. If particles suddenly lose energy in a collision, it might mean that energy has escaped into a hidden dimension. Another possibility is the creation of microscopic black holes, tiny, short-lived distortions of spacetime that could reveal extra-dimensional effects before evaporating instantly. So far, no conclusive evidence has appeared. But the search continues, and with each new experiment, we come closer to either confirming or ruling out these extraordinary ideas. Even without direct evidence, the concept of hidden dimensions reshapes the way we see reality. We like to think of the universe as something we can picture in our minds, something finite and knowable. Yet physics suggests that we may be blind to most of what exists. If extra dimensions are real, then our entire reality, the galaxies, the stars, our very existence, may only be a thin slice of something much larger, a projection of a higher dimensional truth. And once you accept that possibility, it raises even stranger questions. If extra dimensions exist, what might live within them? Could entire worlds or forms of matter exist in spaces we can't touch? Could consciousness itself have higher dimensional aspects we have yet to understand? These are questions that border on both science and philosophy, reminding us that hidden dimensions aren't just a curiosity for physicists. They could hold the key to some of the deepest mysteries of existence itself. If higher dimensions exist, then they are not just curiosities of mathematics. They may reshape everything we know about reality itself. They might explain the deepest mysteries of the cosmos, open doors to entirely new realms of existence, and even offer shortcuts through space and time. To grasp this, let's step into imagination and ask, what would a universe with higher dimensions actually mean for us? Start with something simple, a sheet of paper. To a two-dimensional creature, traveling from one corner of the paper to the opposite corner requires moving along the surface, forward, sideways, zigzagging across the flat world. But to us, in 3 dimensions, the solution is obvious. We can simply fold the paper, bring the 2 points together, and touch them instantly. What seems like a long and difficult journey in 2 dimensions becomes effortless when viewed from a higher one. This is the essence of how higher dimensions might change our reality. If we are trapped in 3-dimensional space, vast distances separate stars and galaxies. Traveling from Earth to the nearest star would take tens of thousands of years with our fastest technology. Yet if space itself can be folded through higher dimensions, those distances may shrink or even vanish. A journey across light years could, in theory, become as short as stepping across a room. Physicists call these possible pathways wormholes, bridges through space-time that connect 2 distant points. Wormholes are solutions to Einstein's equations of relativity, and they are consistent with the idea of higher dimensions. To picture it, imagine again the flatland creature. To travel from one side of its paper world to the other, it might crawl endlessly across the page. But if the page were lifted and curved through a higher dimension, 2 distant points could touch, and the creature could step across instantly. That is what a wormhole could be for us. A tunnel carved through dimensions we cannot see. Of course, wormholes are still theoretical. No one has ever seen one, and even if they exist, keeping them open long enough to travel through may require forms of matter we don't yet understand. Still, the mathematics suggests they are possible, and their existence would only make sense in a universe where higher dimensions play a hidden role. But wormholes are not the only strange consequence. Consider the mystery of parallel universes. In many versions of string theory and brane cosmology, our universe may be just one brane floating in a higher dimensional space. A brane, short for membrane, is like a vast sheet of reality. Our 3-dimensional universe could be such a sheet, stretched out within a higher dimensional bulk. And just as pages in a book lie side by side, there could be countless other branes, parallel universes, stacked next to ours, separated by only the thinnest veil of higher dimensional space. If this is true, then the cosmos is far bigger than we ever imagined. Beyond the stars and galaxies we see lies not just empty space, but entirely separate universes with their own matter, energy, and perhaps even versions of physics. Some could resemble ours. Others could be utterly alien worlds without stars, or with laws of nature so strange that life as we know it would be impossible. The possibility of parallel universes raises haunting questions. Could there be other versions of you living different lives in other brains? Could decisions you make here ripple through higher dimensions, creating echoes of yourself elsewhere? We don't yet know, but these are the kinds of questions hidden dimensions force us to confront. Another fascinating idea involves the very flow of gravity and time. If gravity can leak into higher dimensions, then perhaps time itself may not be fixed in the way we experience it. In our three-dimensional perception, time moves forward relentlessly, one moment after another. But in higher dimensional space, time could behave differently. Perhaps it can branch, loop, or exist as a landscape rather than a river. From a higher dimensional perspective, our entire lives, our past, present, and future, might exist all at once as a single structure. What we experience as the flow of time could simply be the way our limited minds move across that structure. This is more than speculation. Some physicists argue that higher dimensions could allow for forms of time travel. Not the fantastical machines of science fiction, but subtle shifts in how space-time folds and connects. If wormholes or brain interactions exist, they might offer routes not only through space but also through time itself. Of course, with every possibility comes danger. If higher dimensions are real, then the fabric of our universe is more fragile than we think. Collisions between brains could, in theory, trigger cataclysmic events, entire universes collapsing and new ones being born. Some cosmologists even suggest that the Big Bang itself may have been such a collision, two brains smashing together in higher dimensional space, releasing the energy that created everything we see today. The more we explore these ideas, the more humbling they become. Higher dimensions challenge the core of our reality. They suggest that our universe may be just a shadow of something greater, a projection of structures too vast and strange for us to fully comprehend. But perhaps the most haunting thought is this: if higher dimensions are real, then we are already living inside them. We just can't see them. They are not somewhere else. They are here, folded into every atom, woven into the fabric of existence. Like the flatland creature unaware of the sky above, we may be surrounded by realms of reality that silently shape our world. So the next time you look up at the stars, imagine this: the universe you see may not be the whole story. Beyond the familiar three dimensions of space and the relentless march of time, there may be doorways, shortcuts, and entire worlds waiting in the spaces between. Hidden dimensions that, one day, we might finally learn to step into. If higher dimensions exist, one of the greatest barriers to understanding them isn't just physics, it's perception. We live inside our senses, and our senses evolved to survive in a three-dimensional world. Vision, touch, hearing, even the way we move, all of it is tuned to length, width, and height, and to the steady ticking of time. Our brains are filters, stripping away anything unnecessary for survival. Which means if higher dimensions are real, it's entirely possible that we are blind to them, not because they don't exist, but because we were never meant to notice them. Think of your eyes. They capture only a tiny fraction of the electromagnetic spectrum, what we call visible light. Beyond that lies a vast ocean of infrared, ultraviolet, X-rays, and radio waves, invisible to us but real nonetheless. Bees can see ultraviolet patterns on flowers that guide them to nectar. Snakes can sense the infrared glow of warm prey in the dark. Bats navigate with sound waves, perceiving a world through echoes. Each creature lives in its own sensory bubble, blind to most of reality. Humans are no different. We mistake the slice of existence we perceive for the whole. Now imagine if our sensory bubble could expand into higher dimensions. What would we see? It's nearly impossible to picture because our minds are built for 3D geometry. Just as a flatland creature could never truly imagine up, we may be unable to truly imagine the fourth spatial dimension. The best we can do is use analogies. In flatland, a three-dimensional object passing through would appear as a series of changing shapes. A sphere dropping through a two-dimensional world would first appear as a point, then expand into a circle, then shrink again before vanishing. The flatland beings would never see the sphere in its entirety, only slices of it. In the same way, if a four-dimensional object passed through our space, we might see only fragments, shapes morphing in ways that defy explanation, appearing and disappearing without reason. Some theorists even suggest that certain phenomena we label as unexplainable could be glimpses of higher dimensional interactions. Not ghosts or spirits in the supernatural sense, but natural processes that look strange because we can't see their full form. Imagine an object moving through a dimension we can't perceive. It might look as though it appeared from nowhere, then melted back into nothingness. This is where science brushes against philosophy and even spirituality. Could consciousness itself be tied to higher dimensions? Our thoughts, our awareness, the sense of self. None of these can be touched or measured like ordinary matter. Some physicists and philosophers have speculated that consciousness might not be confined entirely to three-dimensional space. Instead, it could interact with higher layers of reality in ways we only dimly perceive. Take dreams, for example. In dreams, time feels different. Moments stretch or collapse. Space is fluid, shifting in impossible ways. Our waking mind dismisses this as imagination, but what if our brains are tapping into patterns of higher dimensional reality, reassembling fragments in ways we don't fully understand? Even more curious are the reports of people who experience altered states of perception through meditation, near-death experiences, or other extraordinary conditions. Many describe sensations of being outside of time, of seeing their entire life at once, or feeling connected to a vast reality beyond the physical. While science approaches such claims cautiously, they raise an intriguing possibility. Perhaps our brains occasionally open a window, however small, into dimensions beyond the ordinary. But what would higher dimensions actually look like if we could perceive them? The truth is, our language and imagination may not be up to the task. Mathematicians can describe 4- and 5-dimensional shapes with equations, but to visualize them is like trying to see color with your ears. Still, we can try. Imagine a cube. Now imagine that cube being extended into a higher dimension, forming what mathematicians call a tesseract or a 4-dimensional cube. Just as a cube casts a 3-dimensional shadow, a tesseract would cast a shadow into our 3-dimensional world. We could never see the full tesseract, only its distorted projection, twisting in ways that seem impossible. The edges might fold through one another. Corners might touch without crossing. It would look like an object alive, constantly changing shape. Now expand that thought further. Entire landscapes, entire beings, entire universes could exist in higher dimensions. To us, they would appear as flickers, distortions, incomprehensible forms. What looks impossible in 3 dimensions might be perfectly natural in 4 or 5. Just as a flatlander cannot understand the fullness of a sphere, we cannot grasp the fullness of higher reality. This limitation forces us to ask a humbling question. How much of reality are we missing? For all our science, for all our exploration, we may still be like children drawing on paper, unaware that a vast sky stretches just beyond our perception. And yet, Our inability to see higher dimensions doesn't mean we cannot reach for them. Mathematics gives us glimpses. Physics suggests their necessity. Technology may one day probe their presence, as accelerators push the boundaries of energy and precision. But perhaps the most powerful tool of all is imagination. By daring to picture a world beyond the one we know, we take the first step toward discovering it. If higher dimensions exist, they might not only reshape our understanding of the universe, they might reshape our understanding of ourselves. Consciousness, time, existence, even the meaning of reality could take on entirely new forms. And if that is true, then the boundaries of human knowledge are far from closed. They are only beginning to open. So perhaps the real question is not whether higher dimensions exist, but whether we are ready to see them. And if one day we do, we may discover that our familiar world of three-dimensional space and flowing time is only a shadow cast by something far greater. A hidden architecture of reality, vast and mysterious, waiting just beyond our reach. And now, we arrive at the most haunting question of all. If the universe has a beginning, does it also have an end? Or could it stretch on forever, without limit, without closure? Some scientists believe the universe might eventually collapse in on itself, a scenario called the Big Crunch. Imagine galaxies reversing their motion, the cosmos folding back, stars and planets falling into one another, until everything is crushed into a single, dense point, a kind of cosmic rewind button. But others whisper about the opposite fate, the Big Freeze. In this story, galaxies continue to drift farther and farther apart, until stars burn out, light fades, and space grows cold and empty. Not with a bang, but with a silence so vast that time itself feels meaningless. And then there's the strangest possibility of all, the Big Rip. Dark energy, that mysterious force pushing the universe apart, might grow so powerful that it tears galaxies, stars, and eventually even atoms themselves into nothing. Space itself ripped apart. Mini-hook. But here's where it gets truly unsettling. What if none of these endings are final? What if the universe is a cycle? Born, expanding, dying, and then reborn again, an endless loop like a cosmic heartbeat? To some, this idea feels almost comforting. To others, it's terrifying. And so, as we stare into the night sky, we're left with a paradox. The universe is everything we know, and yet, it may be something we can never fully understand. An infinite stage where we play our fleeting roles, unaware of the script that lies ahead. So maybe the real question isn't whether the universe ends. Maybe it's whether we can learn to live, to truly live in the mystery of it all.